Hello everyone, Ashwini Manjunath here, presenting my final project for deep learning course, the topic being recognition of emotion from text. Technological advancement is something we can no longer ignore, deep learning being one of those advancements. With deep learning, emotions can be extracted and analyzed in textual data to be utilized in various sectors involving human behavior analysis. We have two segments into this, like one is sentiment analysis, another is emotion analysis. Sentiment analysis being to identify polarity, simply like if the product is bad or good, but emotion analysis provides more granular insights, like if the customer is frustrated, experiencing joy, anger, fear, disgust, based on the text. Unlike traditional machine learning that requires manual feature engineering, deep learning models like transformers, LSTM automatically learn semantic and contextual representations from raw data. We can now look into the dataset that I have chosen, which is Go Emotions from Kaggle. I've used that for my training. Basically, this dataset has a lot of examples, like more than 58,000 of them. This carries actually 27 emotion categories. So the curated comments are carefully extracted from Reddit actually, and then while training my model, I am also using a subsample training dataset, test and validation dataset with an ample number of samples, as you can see shown here. Basic simple architecture behind this is quite not simple, but the architecture behind this is collect the text data, process it, tokenize the text with the predefined emotion keywords, spot the emotion related keywords, analyze the emotion intensity, searching, negation, and then classify into emotion classes. We all know that natural language processing NLP has become so much popular an AI field, which is using computer science and linguistics to help computers understand, interpret, and generate human language, enabling applications like chatbots, translators, and voice assistants by bridging the gap between complex human communication and machine processing. We use all this to analyze the semantic of a text, where we extract the meaning, consider context, and then analyze relationships, not just going by how words and phrases with spelling and structure of words, but in fact actually grasp the actual meaning, um, and relate to one another, how the words and phrases are relating to one another within a larger text space, such as paragraph or the entire document. So here, using machine learning algorithms trained on large amounts of text, we try to make the accurate predictions about the meaning and classify them the same into the emotion categories. So once I took the data set, I tried to, let's go back in here. I loaded the data set and inspected. As you can see here, we have, like leaving the ID and other columns, we have 27 different emotion categories. So I'm pre-processing the text data here, tokenizing, and then coming up with the emotion columns or labels, and then splitting the data into train and validation. I'm using the 70-30 approach here. So I tried first with CNN model. Basically, I wanted to see if these models, how well they can capture and analyze the emotion, recognize the emotion from the text. And then later I compared it with some BERT, Roberta, all those models which are actually much more evolved and meant for emotion analysis, but we'll see that in the later part. So I started with CNN model though. So the filters and the dropout, dense layer, and then compile the model and fit it. And I used 10 epochs. And as you can see, the accuracy was not that great. I only got 49%. So then what I did, I tried with the same CNN model but with some regularized parameters, L2, adding the dropout, and then regularized model fitting, again used 10 epochs on that. Surprisingly, I only got 39% accuracy, validation accuracy. So as you can see here, the training and validation accuracy, the plot, how is it comparing with training and validation accuracy over here? And when I evaluated the model, as you can see, the accuracy was 39% and validation loss was 12%. So then I went one more step ahead, tried with model with callbacks, early stopping, model checkpoint, those things, and then again, tried to compile and fit the model again with 10 epochs. Again, the accuracy was not that great again, like 36%. As you can see the plot here, training and validation accuracy comparison. So then I went ahead and tried transformer model with all the required parameters, average pooling, layer normalization. Again with 10 epochs, but because I was using callbacks, uh, we stopped at 6 with the accuracy, 6 epochs with the accuracy of 42%. And here's the plot for training and validation accuracy. Then I went and tried LSTM model with all the required parameters with again 10 epochs, managed to get the accuracy of 52%. Also provided learning rate here, and then here's the plot for training and validation accuracy, 52%. So here's the summary for all the models that I tried, and then I switched on to the next one, this being very popular BERT model for emotion analysis. So again, first take the training data, test data, separations that I have already made with the CSV ready. But then as you can see, there are differences, in the text. Like some of them are uppercase, some of them are lowercase. So I'm trying to clean all that up over here. And then everything is lowercase now. And then also these are the emotion classes that we want to classify later into. And then once the model is fit, I used 3 epochs over here. The accuracy was much better, as you can see. Validation accuracy 65%, training accuracy 78%. So far I could see that BERT model was coming out really good with its accuracy. So then I tried Roberta. with all the required parameters, with the training arguments, batch size, number of epochs. Again, I tried with 3. So here we can see the accuracy close to 46%. So far I could see that BERT model gave me a good accuracy. If time permitted, I wanted to try much more models, variety, and then changing some of the parameters over here and see how to get a better accuracy. And then I also tried with some sample sentences whether it will predict the emotions properly. As we can see here, the text says, "I'm so excited for my birthday party tonight," and we got the predicted emotion, the score. If it is greater than zero point 0.5, the label was excitement, the score being 80.819. So that's the right prediction. And here let's see another text that I used is, "I just got fired and I'm feeling really down and angry." So here the score was 0.77 with this model, and then the classified emotion is anger, which is right. So pretty good, I would say. Going back with, I've also come up with the results and demonstration, compile them. Some of the challenges that I faced were like generally also right when any text we find, like if there is no facial gestures, like expressions that we can see, just going by the text and then categorizing them into emotion, analyzing them could be much more trickier. So in spite of that, we got a good accuracy, but then these are the challenges we generally face when it comes to simple text, instead of the missing the expressions and the facial gestures part of it. Also, the computational expense. I missed a faster GPU. I also would have liked to try a couple of more models if time permitting. And also, there were various software requirements because of which I had to create 3 different environments to run these various models because they wanted different versions of those packages. So these were a couple of challenges that I faced. The future of emotion analysis looks very promising, though. Natural language processing being very popular, as and when the algorithms are getting more and more nuanced, evolved, and improving, we are getting much more better accuracy. And then the future interaction between computer and human beings is also going to get much better. Some of the lessons learned are like, there is always a multi-model approach that we can take. There are several models, that there is so much in this field that needs to be explored, um, and then analyzed, and then mix and match combination with the models, available models, and then we also put in our own parameters, like more epochs or better learning rate. There is so much more that we can parameterize and see which gives very good accuracy and stuff. This was a very interesting project with a very interesting data set that I was able to work with. Thank you for the opportunity, and we'll take any questions if there are any. Thank you so much.